Can you hear
Okay,
me?
so the final talk is on optimal credit scores under adverse selection, and Andre is giving the talk.
All right. Thanks everyone for coming, and thanks for staying until the last session today. This is joint work with Nicole, who's here at the audience, and my advisor, Rob Townsend. So data is becoming increasingly available, and also there's new tools and methods to analyze this data and extract more information from that data. In particular, in credit markets, this increasing data availability brings the hope that the doors of financial inclusion will open for some of the people who need it the most, like the people who have very short financial histories and don't have credit access, and have a very high value for that credit access. However, if the reason why the market is not working is precisely those information asymmetries and adverse selection in particular, so the fact that as prices increase, the pool of borrowers in this market, as interest rates increase, the pool of borrowers changes. And so the worst borrowers are willing to borrow only the worst borrowers are still willing to borrow at higher interest rates, and the market can unravel. If that's the case, why those financial markets is not working, when you give a little bit more information in these markets to the investors or to the banks, it's not necessarily the case that the volume of transactions or the outcomes as measured by the quality-weighted volume of transactions is necessarily going to increase, and in fact, it can also decrease. And the intuition for that, and one of the intuitions I can give you now, I'm going to get back into it in a moment, but if there's adverse selection, then you're in the second best world, and taxes and transfers could improve welfare. So pulling types together is one way to create implicit cross-subsidization between those types. And when you review information, you're taking out those cross-subsidies. That could be the case that they are improving outcomes in this market. So this brings the question of how can we design data sharing protocols that guarantees that the welfare of the borrowers are always going to improve whenever more information becomes available. So to answer this question, we build on the information design literature and formulate the optimal disclosure problem of a partially informed intermediary with commitment, a platform that seeks to maximize the probability of successful transactions weighted by the size of gains from trade on those transactions. We're going to characterize the optimal disclosure system, and also going to derive necessary conditions that are going to be written as simple 3 rules of thumb that are necessary and that are written in terms of local sufficient statistics that can be estimated in the data. We're going to apply our results to the rural credit markets in Thailand. We think that's a particularly fitting setup because on one hand, there's a fee informal segment, so the gains from financial inclusion are potentially large. And moreover, we benefit from extensive data from the Townsend Thai project that has tracked farmers in Thailand over a period of more than 10 years, collecting data on their balance sheets, income statements, cash flows, and credit histories. So the question we're going to ask is, what features of the data set should be reviewed to investors, and how can we design an algorithm that reviews that information using that data set? And we're going to find that indeed the algorithm we propose improves outcomes, improves welfare in that particular measure by around 4% of the average income of those households. So let's jump right into the model. So borrowers are going to have types omega. That's going to be the borrower's private information. They're going to sell a $1 claim to be paid in the future. And they can sell this claim to multiple investors, and the investors can buy claims from multiple borrowers. We're going to denote the value for the investor as A of omega. And you can think of, if the investors are risk neutral, that's the probability of repayment of that claim for each borrower, multiplied by a discount factor. And the value for the borrowers is going to be denoted B of omega. And you can think of it as additionally incorporating some implicit insurance so that the borrower doesn't repay precisely at the moment when the marginal value of consumption is higher. Or you can think of a borrower who is really impatient because it has a really good investment opportunity now and it has cash constraint, so it really wants the money now. And the platform will have access to signal realizations, Z of omega. That's the features we have in the data set. And we will commit to an information disclosure policy. And after committing to an information disclosure policy, we will review, after seeing those signals, a message, M of omega, that's going to be measurable with respect to the information the platform has. Then the investors, after seeing those messages, are going to compete among themselves by offering contracts to those farmers, to those potential borrowers. And the competition between the investors are going to drive prices up to their expected value for the investors. And if there are multiple prices such that the investors break even, we're going to pick the highest among them. And the reason for that is because otherwise an investor could offer a price in the neighborhood of that price, attract all the borrowers, because the borrowers like higher prices, and make positive profits. So that's the equilibrium as an outcome of the game of competition between the investors. So visually, there are borrowers, investors, and the platform. The borrowers, the platform sees signals that are informative about the credit worthiness of the borrowers and their willingness to borrow. And then review messages M to the investors, and then the investors offer contracts to the borrowers. So the question is, how can we formulate this optimal information disclosure problem? And one way to think about it is that the platform is maximizing over the conditional distribution of messages given the signals to maximize the borrower surplus, which in the case is the total surplus, because the investors are break-even, subject to this constraint that the equilibrium prices and should satisfy that competitive equilibrium condition, that the investors are driving prices up to their expected value, and moreover, they're picking the highest among them. So this problem may seem quite complicated because it has this supremum on the constraint. It also, it's an arbitrary message space, and how do we define this message space? But it can be simplified by noticing two things. So first, without loss, we can identify messages by their equilibrium prices. So if two messages result in the same equilibrium price, the platform can, without loss, combine those two messages into the same message and label that message by their equilibrium price. So the investors are still breaking even, and the platform is attaining the same objective value. And moreover, because the welfare is increasing in prices, the platform doesn't need, and the platform is maximizing borrower surplus, it doesn't need to worry about the supremum on the constraint because while it's maximizing, it's already picking the highest price. So noticing those two facts, we can simplify this problem and write it in terms of a simple linear programming problem where the platform maximizes over the joint distribution, the conditional distribution of prices given the signals subject to the breaking even constraint. So here, sigma is the borrower surplus conditional on the signal z. When it assigns the signal z to a price x, and and the platform is picking the joint distribution phi. That's the conditional distribution phi. That is the conditional distribution of signals, conditional distribution of prices given signals. And the pi is the profit of the investors, and the platform is subject to the constraint that at any price, the investors need to break even. So having characterized this optimal information disclosure problem as a linear programming problem, we can ask under what conditions simple policies are optimal, such as full disclosure. And full disclosure is going to be optimal if and only if any deviation, any feasible deviation from full disclosure does not improve welfare. But as we show in the paper, we can write any feasible deviation from full disclosure as conical combinations of simple policies, simple deviations, where you pick a pair of signals, J and K, it takes some probability out of their full disclosure prices, and assign to a new message M, making sure that you pick the right proportion so that investors break even at the new price. And that's the change in welfare from such a simple deviation. So if full disclosure is optimal, this set of inequalities needs to be satisfied. Moreover, we can specialize to the case where those prices are nearby to each other. And when we do that, we're going to conclude that prices and elasticities of the value for the investor must satisfy an increasing relationship. And I'm going to skip this proof, this graphical proof in the interest of time, but I'm happy to talk about it then offline. And we can do a similar thing with no disclosure configurations and ask under what conditions no disclosure configurations are optimal. And now the complication is that when you take a pair of signals, J and K, and assign to a new message, M, making sure that investors break even at the price M, in general, it's not going to be the case that the investors are going to be breaking even at the original price that you were taking the probability out, the probability of the no disclosure price, X0. But if you take two pairs of signals, you can combine those two pairs of signals and assign them in the right proportions to the price M, to the price M prime, and combine them in the right proportions such that the investors break even at the price M prime, and at the original price X0. And then when you take the limit where those prices that you are considering are nearby to each other, you're going to conclude that prices and the elasticity of value, the elasticity of profits for the investors needs to satisfy a simple affine relationship. And in practice, this means that few signals should be pulled together. If you take 3 signals, in general, they're not going to line on this affine relationship. So generically, you want to combine only a few signals together. So we can summarize those results in 3 rules of thumb. So markets with higher prices should have higher price elasticities of the value for the investors. Whenever you combine 2 signals together, it's going to be the case that you're going to put a signal with a high full disclosure price and a low price elasticity of the value for the investor, with another signal where it has a low price elasticity of the value for the investor and a high full disclosure price. And each message should combine, in general, only 1 or 2 signals whenever you have a finite or a single dimension of heterogeneity. Now, I want to briefly talk about the empirical application we have in this paper. So we have this Townsend time monthly data set that follows around 800 households in 16 different villages for more than 10 years. And it includes all this detailed information on their balance sheets and credit histories. And we're going to assume that the platform has access to those variables in the data set and wants to make use of them to improve credit access to those farmers in Thailand. We're going to rely, so we want to compute the joint distribution of values for investors and for borrowers. And we're going to rely on an identification strategy that leverages the fact that a key player in this market, the Bank of Agriculture and Agricultural Cooperatives, is a government-owned bank that uses rigid set of rules to set interest rates. And those rules are infrequently updated. So we're going to assume that those changes in those rules are random, and use those changes in the rules to identify slopes of supply and demand. So then, because we want to estimate not only the average elasticities, but the elasticities as a function of the observables we see in the data, we're going to employ machine learning methods, in particular causal forest by Wager and Atley, to compute all those heterogeneous slopes as a function of this high-dimensional object, the whole set of variables we have in the data set. And the identification assumption is that those changes, conditional and observables, those changes in the rules are as good as random. And then when we do that and compute the optimal policy and compare to a simple policy, a full disclosure policy, we're going to find that the optimal policy significantly improves upon the full disclosure policy. And the gains from moving from the full disclosure policy to the optimal policy are around 4% of their monthly income. And moreover, the optimal policy selects variables that are much more related to the solvency of the farmers relative to the liquidity concerns of those farmers. So to conclude, we show how to compute and show what the optimal information disclosure policy looks like in this context. And we reframe the problem in terms of local sufficient statistics. We present a framework to estimate and evaluate those current policies and compute the optimal policy. We show that it has substantial gains for implementing the optimal disclosure policy, and our results can be applied more generally whenever adverse selection is a major concern for different markets, such as health insurance, unemployment insurance, and many others. Thanks so much.
Okay, thank you. Questions?
So in the diagram where you showed how borrowers interact with the farmers, I'm wondering what if the borrowers, the lenders can actually interact with farmers after they've seen some communications from the platform, i.e. there's a search cost for the lenders, and how would search cost impact the optimality routines?
Sorry, what do you mean by search costs?
So the lenders can spend some money/effort to see information that you are withholding right now.
Yeah, so what we assume here is that those villages, and there's also evidence that suggests that may be the case, are able to coordinate among themselves and commit to an information disclosure policy. So they are the ones that are setting the policy, and so they're not accepting, they're committing not to go with the investors on the side and tell them what are their characteristics.
More questions?
Sorry if I missed this. How are the lenders doing versus the borrowers under the improved policy?
Yeah, so the lenders always break even the model. So all the gains are coming from the borrowers.
How about in practice? Do you expect they're going to be self-interested, right? So would that change?
Well. Yeah, that's a good question. I think this setup of as in other contexts that people refer to, instead of revenue maximizing surplus, using second price auctions, is kind of similar to the perspective here that the platform wants those farmers to engage and may charge another fees elsewhere, but it's more like a reduced form for a kind of long-term relationship.
Okay, then let's thank Andre again, and let's thank all the speakers in the session. So this concludes the sessions. See you at dinner.